Hey guys, it's Cam here. Welcome back to the Build Room. In this week's episode, we're taking a break from Violet Crumbles, literally, because it's new tool day, and we are building our own bending brake for sheet metal. So stick around and check it out. Okay, so before we get into it, why are we building a sheet metal brake? Now, if you haven't watched the last episode, you should. I'll link to it up here, but basically we're doing a lot of sheet metal work to the rear area of Violet Crumbles, fixing the rusty areas underneath the windscreen, and there's a couple of things that we ran into. Firstly, the outer radius on any of the bends that I was doing in my bench vise jaws, they weren't tight enough to mimic the original angle. So what I'm gonna have to do on one of the areas is go back and weld on top of it to give it a raised point and then sand that into the edge that I need. Now I don't want to do that all the way along. I just want to start off with the right curve to start with, and that'll make things a lot easier. The second thing is, to hold the rear windscreen seal in, I need to recreate the original piece of metal that held the seal. Now that seal is 1200 mil long or thereabouts, and it's a continuous radius in 2 dimensions. So what I want to be able to do is fold up a 90-degree piece of sheet metal and then use the shrinker stretcher to get that the right shape. Now, I don't have anything that's going to give me a 1200 mil sheet bent to a nice radius, otherwise I would have used it on the other pieces. And when looking online, the costs associated with a bending brake that big are pretty ridiculous for something that I'm not going to get that much use out of. I mean, if you're doing sheet metal bending all day long, definitely invest in good tools. But for something like this that I may use only once every sort of couple of months, I want something that I can get away with the least amount of investment possible, because any money I'm not spending there is going straight back into the car. Now, bending brakes are really simple pieces of kit. You can build them out of all sorts of stuff, but the raw materials that we're using today is just mild steel angle and flat bar, and all up, I think I'm still under the $200 Australian mark for what we're doing here. And bear in mind, we are building a big bending brake. This thing's going to be, 5 foot long at the end of the day, 1500 mil, so that it can bend up that 1200 sheet. Now, if you want, look online and shop around, and you'll probably find that you're spending about $1,000 plus on a brake at that size. You can get really cheap ones that are 600 mil or 900 mil or something like that, but I don't want to have to run a weld in the middle of that thing. And later on, I've got some projects that we may be using a bending brake to do some panel work with, and those are going to need to have long brakes on full panels, so I can't build them in 2 pieces. Now, for a sheet metal bending brake, there's really just 3 main pieces. You have a bed for the materials, you have a clamping bar to hold the materials in place, and then you have a bending leaf. So I've got some props here that we can look at in a little bit more detail. If we picture the corner of the bench top as the bed for the material, and we'll take this box of welding wire as the clamping bar, and we will pretend that this piece of sheet metal is the bending leaf. Basically what we're looking to do is to clamp our materials in here. So that's held in place, and we move it right to the edge, so we've got a nice clean thing to work on. And then with our bending leaf underneath it, which would be hinged on either side, then all we're going to do is, with this held in place, we bend the bending leaf up, and that's going to leave us with a bend on our material. Now, a couple of things. You'll notice the edge or the radius on this outer edge is not A, straight, B, sharp. Now, the better you build your bending brake, the better a radius you'll be able to get, and the more accurate it will be. You've got to look out for things like the deflection of the metal, especially when you're talking about the size of a sheet metal brake that we're doing, because no matter how thick steel is, it's always going to want to deflect a lot. It's very good under tension and even compression, but it will deflect a certain amount. So the more accurate you can get those 3 pieces, the bed, the clamp, and the anvil together, next to each other, the better aligned they are in terms of as it rotates on its axis to fold sheet metal over. That's all going to affect the final product that you get out of your sheet metal brake. We're going to do some subtle modifications to this one to not only address the issues of deflection and things like that, but also make it a little bit more usable. Now, I want to build this thing attached to the bench. It may not be permanently attached, I might be able to remove it later, but I'm going to need more space than I have. I've got 1350 here at the moment, and I need that full 1500, I think. So The bench vise is going to have to be moved, and then we're going to set up some equipment. So let's do that, and then we'll get into building the first part, which will be the clamping bar. So we'll see if we can pinch those other 2 holes for now. Yep, good enough. All right, and now we need to set up the welder. So this is set up currently with 0.6mm wire for doing thin sheet metal stuff like we've been doing on Violet Crumbles. But the thicker metal that we want to weld today is also going to mean we need thicker wire in our welder here. So we need to replace the spool here. We're going to go up to 0.9mm wire from 0.6. Changing to that thicker wire also means that we're going to need to swap out the guide runner in here for the 0.9mm runner, and we're also going to need to change the tip on the handset. And once those few simple things are done, we're then going to use the settings guide inside the welder to do an initial setup of the power and feed speed on this so that we get a good starting point for that thicker material, and then we can just tweak as we go. Now the clamping bar is going to be a 75mm by 6mm flat bar, and it's going to have the 50 by 50 by 6mm right angle on top of it. So what we're going to end up with is a bar that is triangle shaped on top, which means we can bend all the way past a 90, all the way to a 45. Now there's a couple of reasons you might want to do that. Firstly, if you're just trying to bend a 90, and a lot of the simple brakes that have just either square tube or a 90-degree laid sort of flat like that, now they're going to let you bend up to that 90. The problem is metal will spring back once you bend it. So you'll bend it up to the 90 and then you'll drop the bending leaf down and the metal will spring back a little bit. So you never get your true 90. So you want to be able to bend past that point. There's also other shapes that you might want to be bending into, including diamonds and things like that, and you're going to need to go past the 90 for those as well. So the first thing that we're going to have to do here is determine what size we want the clamping bar to be. Now I want to bend a 1200mm sheet for that rear parcel shelf area, which means I need a little bit on either side of that. So we're just going to go to 1220, and we're going to put the clamping mechanisms and things like that outboard of it. The reason for that is the way we're going to build this is we'll have this right angle, and that will sit on top of our 75mm flat bar. But because I want the final product to be a 45-degree angle all the way along, I can't just drop this on top of the 75mm sheet and weld it together. What I am going to have to do is put these two together and position it such that the angle is right towards the back of the flat bar, and then I can grind and sand this piece of metal here onto a 45 so that it all matches up. And what I'll do is weld in the little gap between them. I won't weld it all the way along because I think I'll get way too much warpage like that, but I'll just put some sort of 1-inch stitches all the way along. Then once I've done that, this will be capped off with a piece of 90, and that will be the point that we drill a hole for our clamping mechanism. So let's get that done, and then we'll regroup and talk about the bending leaf and the bed. There we go, 12-20mm long. I'm going to push this back. All right, so we are done with the clamping bar and I'm absolutely stoked with the finish. It almost looks like it's milled, but it isn't. I tried a bunch of different things to get the 45. I roughed it in with a flap disc first, and then I tried going down to roll lock disc, which I was using sort of to get as flat as possible. And then I even tried a belt sander. The weight of that shredded a belt almost immediately, so that wasn't that great. But then I came back to the flap discs, and what I figured out, and the tip for you guys at home, is there are two different types of flap discs. So firstly is the bevel on the disc itself. So the red is a flat disc, a type 27, and it is meant to grind between 0 and 15 degrees. This one is a type 29 and it has a bevel on it. It's about a 20-degree bevel and it's meant to grind at between 15 and 25 degrees. So this one's really good for grinding down worlds without gouging. And obviously this one is more suited to that milling style flattening down of surfaces. And the second difference is the way that it mounts to the grinder. So now the type 27s have a bigger recess here to accommodate the bolt of the grinder and the gland nut. So that ensures that when you are grinding flat, neither of these touch the workpiece and damage it. So yeah, you can get it nice and flat on the side there and get that really nice smooth finish. Now it's on to the bed and the bending leaf. Now this one is going to be really tricky because we need to make sure that we get these close together with a high degree of accuracy. And if we look in close, we've got the bed here, we've got the clamping bar on top of it. I've already started flattening this out a bit, it wasn't 100% flat. And then we have the bending leaf here. Now the bending leaf is going to have to flip up like this, but obviously if we're trying to flip it past the 45, I would have to cut it there to get it through here. So we are going to be clearancing this, and then we're going to cut a notch out of here so that it will basically flip underneath this piece, because we do need a fair amount of meat here because that's where our hinges are going to be. Now our hinges are just going to sit in like that. They'll have to go further down. We're trying to get the pivot point here just above the leaf and nice and even on both sides. So we end up straight and we end up close together with these two things. So once this is cut out, obviously there's going to be a reduction in strength, and this bending leaf, because it is just flat steel, is going to deflect quite easily up and down. So the 45 is going to go on the back of it like so, to provide strength, and that will likely also have to be clearanced to get around the mounting bracket. The other thing that I want to be able to do here is for this bar to be able to drop all the way down flat. Now, if you think about these together, if they pivot at the top, they're going to interfere with each other as soon as they go past flat. So we are going to have to cut both of these pieces with a 45-degree angle on the back again. So lots of grinding, lots of 45s. So let's just dive into it. I do think that I might have to have a couple of goes at putting these hinges on. I'm sure I'm not going to get it right the first time. But yeah, we'll have a crack and see how we go. All right, so the base and the clamping bar are pretty much there. They're all welded together. It articulates really well. It's bolted in and recessed into the bench now, and the reason for that will be important later, but doing so has also removed that height difference where this was a little bit sort of under tension. So bolted down, it's nice and flat, really small gaps here, really tight tolerances, which is awesome. Now it's time to get the clamping bar on. And what we're gonna do is just temporarily mount the clamping bar with some rando bolts. And with that bolted in place, then we can start clearancing the bending leaf and also the top of the clamping bar. Now I'm gonna start with the clamping bar because we can afford to sacrifice a fair amount of this. We'll get it cut probably along there, down to the actual face, and we'll mill that flat again. And then the bending leaf itself, we're probably gonna go through and cut sort of around this level, all the way down into there, and I will plate it in here so that it's still triangulated and has as much strength as possible. So let's get that done, and then we will be able to do our first test bend. right, so we've now clearanced both ends of the bending leaf. So we can lift this up now and bend to the full 45 past the 90. I know that's a little bit back to front. And we're actually touching the clamping bar along the back here. So that is basically a working bending brake. In fact, let's do a test bend now. All right, so we've got this clamped in as tight as we can. Let's see if we can get it to a 90. All right, that's not too bad. Let's go the rest of the way. All right, so this is the piece that we bent up. It shows a couple of things. Firstly, the premise that we've gone to build this with tight tolerance and that is sound, and it's doing what I want where it's working properly. So you can see if you look at the end of this piece, I'll try and get it to focus there. So you can see the edge of this is very tight. The internal radius here is really only the width of the edge of the blade that I've put in it. And that's because it was clamped nice and tight and was exactly where I wanted it to be. Now, the other end, so as we move towards the middle of the bar, we start to get some lift and some play. Basically, when there is movement there and the bending leaf moves away from the clamping bar, you get a rounder edge. So this end here is far less tight on the internal radius than that one. This is the sort of bend that we want when we're going to do that rear section on Violet Crumbles, that rust repair. This is no bueno. Now that stems from a couple of things. Firstly, if we look at the clamping bar bolted down, you can see it is high in the center. So if we take our ruler here, we are flat on the deck there, but as we get to the middle, we've got a gap, and that's because the clamping bar is high in the center. Basically, when we're welding this on, it's warped slightly up, and that's no good. So we're going to correct that. The second one is that when we're looking at this 1200 mil difference, we really do start to get right to the edge of what is possible in terms of a bar like this not deflecting when it has no other form of reinforcement. So we're going to take one more pass at this. There's a few little things I want to tweak. I need to stop the flex in this bar and correct any warping. I also want to fix up these clamping mechanisms here on the end of the bar. I'm not happy with those. Basically, I drilled the bolt here too far forward. I don't know what I did. I'm out by about 5 millimeters. I must have just messed up my maths. So that needs to go back. And I also don't like the fact that it's clamping at the front. I was trying to keep an even pressure on the bar, but that hasn't worked. So we're gonna move that back. It'll probably involve cutting this entire piece off and welding a new one on both ends. We're also gonna build out a big tension bar that will keep this thing straight, then general tightening up, and we'll come back and look at the finished product. and there it is. What a difference a coat of paint makes on a few little bits. Now, let's have a look at it in a little bit more detail. So, we have the limiting brackets in place. We've got some nice zinc hardware in there, which looks pretty cool. Now, those are there to stop the clamping bar moving backwards. The reason we want to do that is twofold. Firstly, when we're bending big sheets, we do put a lot of pressure on it to push it towards the back, and this will stop it moving backwards. But also, it gives a really good reference point when you're trying to set the bar up to ensure that the bar can't move any further back than you want it to be. So you basically push it all the way to the back, it'll hit those bolts, and then you just tighten down the clamps and we're good to go. Now the clamps, put some T-handles on the top so they're easy to use, don't need a spanner for them. And I also put some springs underneath. And those springs, basically when you let these clamping handles off, it will lift the bar automatically so that when you loosen them off and you want to put your new piece of metal in, you don't have to try and lift this, because if you're using two hands to feed metal in, obviously then you need a third person to lift the bar. And then finally, we have the tension bar attached. Now, where this design differs to most that I've seen people do online is that this one is removable. So you take out the two bolts on either end and this whole bar comes off. The reason for that is if you bend something up and then you bring it out and you want to bend it up again so that you create a U shape, you're going to start running into the tension bar. So in the circumstances where I do want to do that and I want to bend something deep enough to go through here, I can remove the tension bar and flip those up. So it just makes it more versatile. But yeah, I'm going to call that a massive win for the day. It's, you know, everything moves really nice and smoothly. It doesn't pick up anywhere. You know, it looks so good that I decided I might as well put the name on it. We've got these strong plumbing bars as handles. I was originally going to use some thin wall pipe, but these are detachable, and detachable becomes important in a sec. Now, the only other things that I haven't done is I didn't put a tension bar on the bottom. I don't think it needs it. When we try and bend up the 1200 mil in the next episode, we will find out whether that's true or not. If it does need it, I can add it in pretty easily later. Everything's where it should be. Everything's moving nice. I couldn't ask for more. The other feature of this that was important to me is my bench space. So I haven't got the vise on the bench at the moment, but that does still fit, which is good. So I can run the bench vise and the bending brake at the same time. But this is my only bench and it's pretty tight in here. So the thing that was also important to me is the ability for this just to fade away into the background. All we need to do is disassemble the clamping bar, remove the back stops, and then the handles for the bending leaf. And all of a sudden, this thing now will fold down flat, flush with the bench top, completely out of my way, which is a massive win because I've seen a lot of people make these removable, so the whole unit comes off. But man, that bending leaf and the base there are very heavy. This whole thing weighs a lot, and it's not something that I want to be continually trying to lug in and out all the time. So this way, some moderately heavy pieces can be shifted to the side and I can keep working as normal. So, did we build the ultimate bending brake? Well, we have for my use case. Yours might be different. I'd love to hear what you do different down below. And while we're on the subject of comments, remember that we have the t-shirt giveaway happening. I know there's been a big gap between the last episode and this one. I've had some stuff going on. I'll explain that in the comments for those of you that are interested. Thank you to everyone who reached out as well. That was really nice of you all. But we have the t-shirt giveaway going, and all you need to do to make sure you're in the draw is to have a comment in the comment section. And be smart and go back to the other episodes and comment on them as well, because you might as well be in it to win it. So anyway, I've done a few test bends and I'm really happy with them. The big test for this will be in the next episode where we bend that 1200 mil sheet. So make sure you stick around for that one. Like, subscribe, hit the notification bell so that you actually get told when it comes out. Other than that, if you're new to the channel, I'll put the full Violet Crumbles series up here and I'll put some of our other great content down here. So that's it for today. Thanks for watching and I'll see you next time on The Build Room. Bye for now.